Students, so welcome back to the online classes of Standard 12 Maths. Today we are going to discuss an important topic regarding adjoint of a matrix, and subsequently we will find how to find the inverse of a matrix using adjoints. Okay, so now let us proceed. So first let us conclude the discussion on adjoint of a matrix, right? If you recall, in the last class I have talked about minors and cofactors, right? So adjoint of any matrix A, this is written as ADJ of A, it is nothing but the transpose of cofactors. I repeat, adjoint means the transpose of cofactors, right? It will be clear if I take an example. Please see. Suppose I want to find adjoint of a 2 cross 2 matrix. Let me see. This is 1, 2, 3 and 4, right? So first step is you find the minor first. Minor of A, it is first minor, it will be obtained by removing 1. So you remove this row and this column, what is left? This is 4. Similarly, for 2, you remove this row and this column, you will be left with 3, right? Similarly, for 3 you will get 2 and for 4 you will get 1, right? This is the minor. And for cofactors, you just take the sign convention. This is positive and this is negative, and this is negative and this one will be positive, right? So this one will be positive, that is 4, then minus 3, then minus 2 and 1. Then your adjoint will be nothing but transpose of cofactors. Look at this. This is the transpose of cofactors. Cofactor, and you take the transpose of that set, right? So what I get? If I transpose this one, I get 4 minus 2 minus 3 and this one will be 1. So look at the original matrix, and this one is the adjoint. For a 2 cross 2 matrix, it makes our work easier. Please see, here the diagonal elements are interchanged. That is, 4 comes in 1's place and 1 comes to 4's place. Then the sign of the non-diagonal elements are changed. You can see the diagonal elements are interchanged, that is 4 1, and the sign of the non-diagonal elements are kept like this, right? So for a 2 cross 2 matrix, it is very easy, right? Let me save this page. For example, without also finding minor and cofactors, you can find directly adjoint. If I take A is 2, 3, 4, 7, and I asked you to find the adjoint of this matrix. So simply you write it like this. You exchange the diagonal elements. Exchanged. That means here 7 and here 2, right? So here comes 7 and here comes 2. Then the sign of the non-diagonal elements are changed. This is minus 3 and this is minus 4. Another example, if I ask you A is 1, minus 2, 3 and 7, suppose. I asked you what is adjoint of A, your answer should be just exchange the diagonal element. This is 7 1, this is 2 and this is minus 3. Okay, so this is how we find the adjoint of any matrix for a 2 cross 2. Now for a 3 cross 3 matrix, we have to do a bit of work. So let us start to find out the adjoint of a 3 cross 3 matrix, right? Let me take a 3 cross 3 matrix, right? Suppose I take A is equal to 1 minus 1, sorry, 1 minus 1, 2, and this is 2, 3 and 5, and minus 2, 0 and 1, right? Then first you find the minor. For minor, what you do, you write a big matrix like this and you make provision for 9 elements. 1, this is 2, and this is 3, this is 4, this is 5, this is 6, and this is 7, 8 and 9. Then for this you remove this row and this column, then you write the remaining elements, right? So what you do, for this you write 3, 5 and 0, 1, right? Then come to this one. Here this is for this, you remove this row and this column, the remaining things you write down, right? So it will be 2, then 5, then minus 2, and at last 1, right? Next, for this you remove this row and this column. This will be, look at this, this will be 2, 3, and this one is minus 2 and 0, right? Similarly, for this one you remove this row and this column and write the remaining things, right? So this one will be minus 1 and 2, and this one will be 0 and 1, right? Similarly, you remove this row and this column, this row, this column and this row, what will be left? Please see, this will be 1, 2 and minus 2 and 1, minus 2 and 1. Similarly, for this element you just remove this row, this column and this row, right? So what I get, this column and this row is gone, 1 minus 1 and minus 2, 0, right? So it will be 1, I repeat, 1 minus 1 and at last minus 2 and 0. Similarly, for this one you remove this row and this column, the remaining things you write down, right? So this one will be minus 1, then 2, then it is 0 and this is 1. Similarly, for this element you remove this row and this column, what I am having, this is 1, this is 2, right? And this will be 2 and 5. Next, you remove this row and this column, this is 1, minus 1 and this is minus 2 and 0, right? So now let us calculate the things properly. Here 3 into 1, that is 3 minus 0. So answer will be 3 here, right? So here it is 3. Next, this one 2 into 1, it is 2, minus minus it will become plus. So 2 plus 10, which will be 12. Next it is 2, then minus minus 0, minus minus it will be plus, it will be 6, right? Next, minus 1 into 1, which is minus 1. Next it is 1 into 1, that is 1, plus 4, which is 5. Next, 0 minus 2, which is minus 2. Then minus 1 into 1, which is minus 1. Then 5 minus 4, which is 1. Then 1 into 0, that is 0 minus 2. Clear? So this is our minor, right? Then for cofactors, what we do, first let me write the minors properly, that is 3, 12, 6, minus 1, 5, minus 2 and minus 1, 1, minus 2. So I have to recall this one, 3, 12, 6, minus 1, 5, minus 2. Let me tell it. So here minor I get, this is 3, 12, 6, then I have to search for this one, 3, 12, 6, then minus 1, 5, minus 2, right? Minus 1, 5, minus 2. Minus 1, 5 and minus 2, and at last I was having this one, minus 1, 1 and minus 2, minus 1, 1 and minus 2, minus 1, 1 and minus 2, right? So this is the minor of this. Then for cofactors, what you do, you just change the sign of these 4 elements. Yesterday I have talked about these 4 elements, and rest of the remaining elements are as it is. 3, change the sign of the encircled elements. So it will be minus 12, and this is 6. Again this is 1. I have changed the sign of encircled one. This will be 2, and this will be minus 1, and this will be minus 1, and this will be minus 2. Then at last my step is adjoint. Adjoint of A is nothing but the transpose of cofactors. It is the transpose of cofactors. That means I have to transpose the above set. So if I transpose, what I get? 3, 1, minus 1, then minus 12, 5 and minus 1, and at last it is 6, 2 and minus 2. So this is how we find the adjoint of a 3 cross 3 matrix. So this is very, very important. Adjoint is required for finding the inverse of any matrix, right? So I will be directly taking the formula for finding the inverse of any matrix by using the adjoints, right? So let us proceed further. Our next topic is inverse of a matrix. First one is condition is any matrix A. Suppose I take the matrix to be A. Condition is your determinant of A must not be equal to 0. Then only inverse exists. Otherwise it will not exist, right? And the formula is, for any matrix A inverse is given by 1 by determinant of A into adjoint of A. I repeat, A inverse is given by 1 by determinant of A multiplied by adjoint of A, right? So let me take an example. Question is, if A equals to 2, 3, minus 4 and minus 6, then find A inverse, right? Then first step is to find determinant of A. Your determinant of A is determinant of this is 2, 3, minus 4 and minus 6. This is minus 6 into 2, which is minus 12, and this will be plus 12, because minus minus and it will be plus. So 0. Hence, as I have told, if determinant of A becomes 0, so A inverse doesn't exist. A inverse doesn't exist, right? So remember, A inverse, it is not that A inverse will always exist. A inverse will exist if and only if determinant of A is not equal to 0, right? So now let us proceed. Question, if I ask, if A equals to 1, 2, 3 and 1, find A inverse, right? So first you find the determinant value of A. That is the determinant of 1, 2, 3 and 1, that is 1 minus 6, which is minus 5, and A inverse formula is nothing but 1 by determinant of A multiplied by adjoint of A. So this is 1 by minus 5 multiplied by adjoint of A. As I have told, for a 2 cross 2 matrix, finding adjoint is very easy. What you do, just exchange these elements and change the sign of these elements, right? So that is 1, 1, exchanged, they are same, and minus 2, and this will be minus 3. So this is the value of inverse of A. So for a 2 cross 2 matrix, the life becomes easier, right? Let me take another 2 cross 2 examples, then I will proceed for a 3 cross 3, right? Suppose I take A equals to, this is 1, 2, 3 and 9, suppose, right? Okay. So now find A inverse. My question is find A inverse. For that, first I will find determinant of A. Determinant of A, it is determinant of 1, 2, 3, 9. So this is 9 minus 6, which is equal to 3. Then your A inverse will be 1 by determinant of A into adjoint of A, right? So 1 by determinant of A is 3 into adjoint of A. This is nothing but you exchange these elements and change the sign of these elements, right? If I exchange, this will be 9 and 1, and this will be minus 2 and minus 3. Clear? So this is how we find the inverse of a 2 cross 2 matrix. Now let us proceed for a 3 cross 3 matrix, right? Suppose I ask you if A equals to 1, minus 1, 2, 3, 0 and minus 2, 1, 0 and 3. You have to find A inverse. Our question is find A inverse, right? For that I have to first find determinant of A, right? So for determinant of A, it will be 1, 0, minus 2, 0, 3, minus minus it will become plus, then it will be 3, minus 2, 1 and 3 plus 2. This is the determinant. This is 3, 0, 1 and 0. 1. This one will become 0 plus 1. This one will be 9 plus 2, which is 11 plus 2. Again this one will be 0. So the answer is 11, which is not equal to 0. Hence A inverse exists. So here this is the first step. I ensured first A inverse exists and determinant of A equals to 11, right? Now let us find the minor of this set first. For adjoint, I have to proceed for adjoint then, right? Our A was, let me write it in this corner. Our A is equal to, the elements are 1, minus 1, 2, then 3, 0, minus 2 and 1, 0 and 3, right? Clear? Now let us find first minor of A. For that I have suggested you to make a big bracket, then make special provision for 9 rooms or 9 determinants, right? Then you remove this one, this row and this column, right? So what is left now? You write it down, 0, minus 2, 0, 3. Similarly you remove this one and what is left you write it down, right? This is 3, minus 2, then 1 and 3. Similarly you remove this one, you will be getting 3, 0, 1, 0. Similarly for this you remove this one and this one, what is left you write it down, right? Minus 1, 2 and 0, 3. Similarly for this one you remove this one as well as this one, right? So what is left with me is 1, 2 and 1, 3. Similarly for this element you remove this and this will be 1, minus 1 and this will be 1, 0, right? Then you remove this one first, minus 1, 2 and 0, minus 2, right? Next you remove this one also. This one, what is left here? 1, 2 and 3, minus 2. Similarly you remove this one, 1, minus 1 and this one will be left is 3, 0, right? Now the values are like this. This is 0, first element. This is 9 plus 2, which is 11 and this is again 0. This one, this is minus 3, this is 1, 3 minus 2 it is 1 and this is plus 1, right? Then this one is 2, minus 2, minus 6 which is minus 8. Next this is 0, minus 3 it will be plus 3. So 0, 11, 0, minus 3, 1, 1 and 2, minus 8, 3. I repeat, this one is 0, 11, 0, minus 3, 1 and 1, 2, minus 8 and 3, right? So I get minor of A is, this is 0, 11, 0, right? Let me check it. What were the elements? Minus 3, 1, 1, 2, minus 8, 3. minus 2 1 1, next it is minus 3 1 1 it was, and 2 minus 8 3. Minus 3 1 1, 2 minus 8 and 3, right? Now after getting minor of a, most of our work is done. Then you find the cofactor. For cofactor, you just change the sign of these elements, right? After changing the sign, you write it as 0 minus 11 and 0. This is 3 1 and minus 1. This is 2 8 and 3. Then after minor and cofactor, you just do it like this. Find the adjoint. Adjoint is nothing but the transpose of cofactor. So you transpose this. This one will be 0 3 2. Next it will be minus 11 1 and 8, 0 minus 1 and 3. Then at last my job is to find A inverse. It is 1 by determinant of A into adjoint of A. Our determinant of A, it was 11. So you put the values in place of this. So our final answer is A inverse. It is equal to 1 by 11 into adjoint of A, that is 0 3 2 minus 11 1 and 8, 0 minus 1 and 3. So this is how we find the inverse of a matrix using adjoint method, right? So there are many questions related to adjoint, but I would like to give you a few questions for your practice. So your homework is NCERT exercise 4.5, and our question number, you solve a very few questions. This is 5 to 11. So these 7 questions I am giving you, and before the vacation I will be giving you some of the holiday homework to complete this. We are on the verge of completion of this chapter. So finding inverse and its application is there in the next topic, and how to apply this technique to solve linear equations using the inverse of a matrix. So but you first learn how to find the inverse properly, then only we can proceed. Okay, that's all for today. Thank you very much.